I'm sorry for you that you can't hear the keynote by having, but yeah, it wasn't like manageable in a different way. And anyways, yeah, I welcome you on the reproducibility panel, and yeah, we will have the panelists here in order of the presentation, which is Britta, Rosa Mingen, Helmut Dolaisch, and Min Chen. And the panel will be like that everybody will have a short talk where he basically will give some hints on the discussion and some controversial things to talk about, and then we will have a short discussion about each of the small talks, and then I hope a longer discussion which can also last till the lunch afterwards. And yeah, so I hope you enjoy, and I hope that we can really build something out of it now and do something serious.
So can we switch?
It's not
All right. Okay. So I will start with a little bit of nomenclature. So we've heard a little bit about verification and validation. So verification was concerned with the problem, are you building it right? So if you have a piece of software, for example, does it have bugs, or more or less, how many bugs does it have? To the science. And producing a good verification is very hard. So for example, there was 2 papers by T. Etienne, one at 2009 and one at 2011, sorry, that's wrong, I think. This was also mentioned by Paul. A whole paper just on verification of algorithms, so finding a common culture on verification is really hard, which was also the result of the this week panel last year on verification validation. So, now about validation, it's the other question, are you building the right thing? So is the thing you are building actually solving the problem that you are trying to solve? Does the model represent what you're trying to model at all, the real world phenomenon, whatever that is? And that's even harder. And we've seen that in previous talks. So, but what about the third thing? That's reproducibility. It should be the most basic standard. And Paul mentioned some issues with reproducibility, so what reproducibility means. And we could argue a little bit about what it means really, but for now let's just assume it means that code, binaries, and data is available, so that everyone can really reproduce the results of a paper. And we know that this is not always the case in the papers we see. So the first question is, of course, so why do people not put their source code or their software or something online? Yeah, so, okay. And fortunately, there was a study recently by Victoria Stun, 2010. It's called The Scientific Method and Practice, Reproducibility in the Computational Science. And she conducted a survey, an empirical study of sharing behavior at NIPS, that's the Neural Information Processing Systems Conference, Machine Learning Conference, with about 2,000 participants, but only 134 took part in the survey. And she asked them the question, so why do they share code and data, or why don't they share code and data? It gave many reasons that would influence them to share, or influence them not to share, and the participants had to rate this. Okay, so I'll first talk about the reasons. So why should you share your code and data? So this is the top 10 reasons you figured out. And number 1 is, of course, encouraging the scientific advancement, encouraging sharing and having others share with you. And there's many other things, like a community member, or the increase in publicity, this more personal motivation for sharing stuff. I will more highlight the first 2 things. So when you think about encouraging scientific advancement, you could take a second and think about how often you use a library, or how often did you use a data set by someone else, and see if the method really worked or didn't work, or you could plug it into your own system and didn't have to implement it yourself, and how often it helped you, even if the code maybe was crappy and crashed half of the time. But anyway, it got you an idea if this works for you or not. Okay, so there's definitely a reason to do that. And the other, of course, encouraging sharing, and others share with you is also a big issue, because once other people also start to share the community will prosper and flourish and will be quicker in having results and all. Okay, so I'm not going to talk so much about the other reasons. So one thing I want to mention I found funny was that at place 14 also becomes conforming with the requirements of the scientific method, at place 14 only. And there's a gap of 24% between increase in publicity conforming with the requirements of the scientific method, which tells us something about maybe, I mean, it's funny, but also tells us something about what would maybe make people share code and data. So it's probably not moral science. Oh, so how do I do that? Start again. Okay. Something? It's a pity. So what do I do?
Oh, how about you leave it there, like that? Like that?
Yeah, I can do that. But then you see my funny notes. Okay, so.
No, they won't.
Yeah. Okay, it didn't take too long, I think.
Yeah, it's okay.
It didn't take too long. Okay, so much for the reasons why people share their code. And now for the reasons why people not share their code and data. And it's not so surprising that number one top vote, far out, was of course the time it takes to clean up and document for release. And I think we can all sign this, because it really takes a lot of time. Usually we do not have time to do that. Especially, I think, in visualization, because there's a lot of interactivity going on. So having a proper user interface and debugging it and making sure it doesn't crash takes an awful lot of time. So we all know that. And then, of course, dealing with questions from users about the code is also really, really hard. So, and there's other things like IP issues, and the other panelists will talk about them, but I will just focus on the first two issues. So, what does it mean? It takes too much time. We don't have the time. And at this point, you could say, well, so what? You have to be a good scientist, or you want to be a good scientist, or you want to be popular, as we found out before. So just work harder, right? It's not that easy, because we are in a dilemma here. So what is the dilemma? So what's the prime directive in science? And we might think, yeah, well, we want to, I don't know, bring progress to society, or we want to be good scientists, or we want to observe things, or find things out, or this is why we became scientists. But when it actually comes to our daily work, what we do, I think the prime directive really is publish or perish. So, and by publish, I mean papers. We need paper output and a high output. So you have the choice. You can open your code or binaries and data, or you cannot open your binaries and data. And if you do open code, binaries and data, what you have to do is you have to clean up the code, you have to write a documentation, you have to create a web page. That's also not always easy, so, you know. And then you have all these user questions about why does that not work, why does it not work on my data, and so on. And the benefits lie in the far future. And even though there are many benefits, you won't know if this will ever happen. On the other hand, if you don't open code, binaries and data, you can start working on the next paper immediately. So, why care? Right? So, how do we deal with that? On the one hand, we know that it would help the community a lot, and that we would all be quicker if once we had everybody publish their stuff, because we could build up on stuff of other people. But on the other hand, we're stuck because we just cannot bring the amount of work. We don't have the time. And there's other communities having the same problem as well, not just visualization. And one is, for example, the database community. Mm-hmm. So there's a conference, it's called Sigma, it's a special information group, special interest group, on databases. And they introduced a new thing. They don't call it a badge of honor, but it is sort of a badge of honor. So what the idea is that they don't punish, but they reward. So instead of saying, okay, you're not a good scientist, you cannot have your paper here, they reward those who open code, data, and binaries, and let other people reproduce their results. So what they do is they award two labels. One is the reproducible label. It is experiments could be reproduced by a committee. And the other is the shareable label. That is, the experiment could be reproduced, and they are also open to the public. That is an URL for download or something like that is provided. And they have this now since 2008. And I can talk a little bit about the results from 2011, because in 2012 it was only 1 month ago or so there's no results yet. So 2011 was like this. So you submitted your paper, just normally, and then received an acceptance of notification. And at the same time, or maybe a little bit later, you received an invitation to submit software and data. So what this means is that the acceptance of your paper is still independent of if you give out code and data. So that wouldn't hinder you in that respect. But you can get this additional badge if you submit your software and data a month afterwards. And then there's 2 months where a committee could review the whole thing and try to reproduce the results that were in the paper. And at conference start the notification was announced, if or if not it could be reproduced. Okay, and so do people like it or not? They also have some results. So in 2011, 35% of authors submitted code and data to this badge of honor committee, and in fact 25 of them were repeatable. And you can see here on the right side some statistics on that. And there's a very, very slight increase in how many people submitted, but it's not so much. And in percentage, the papers that were repeatable are rather stable. But anyway, it's an accepted thing. So, okay. And the greatest success, I think, of this thing is it will be implemented in the VLDB conference in 2013. That's the very large database conference. Who picked this up also and found it's a good idea. And now the question for this panel that you should think about is: so would you participate in such a process? Would you think would this encourage you to open your code data? Do you believe? Oh yeah, okay. This is fit to judge the research, or do you have a totally different approach in mind? And think about this in particular in the light of the other arguments you will hear now. And I also want to thank some people.
Thank you, Britta. And I think we can also have already immediate questions to this and work. So are there specific questions to this? Yeah.
Yes, I'd like to take issue with this notion that it takes forever to clean up your code and you have to make it work perfectly and it has to be debugged and everything. I think that's exactly the wrong approach. If you're talking about prototypes and we're talking about some research, the point is not to deliver a product that you can sell and that's going to run forever and for everybody, but the point is to provide the code that proves that what you did is true. And I think it's actually shocking that if 35% of those people submitted code for Sigma, but only 25% were actually reproducible with their own code, I mean, what about the rest of those 10%? I mean, what happened there? So I think there are some issues, but people just kind of overplay those, a lot because they just don't want to give their code away. And I think we need to rethink how we work. And I think your points on scientific method are really very important because we're not a science and we're not trying very hard. So unless we care about this thing and we really want to do something that's scientific, it's just not going to happen. So I think we need to ask ourselves whether we're just going to play around and just writing things that may or may not be true and may or may not be reproducible, or we actually are a science where you can actually prove things and you can actually reproduce things and you can rely on them.
Yeah, so about the 10% gap, so I didn't talk about this explicitly, but in the paper they said that the problem with the 10% was more or less that the setup phase failed. So people just submitted software, but the installation didn't work, or the hardware was not available, or something else crashed, or whatever. So this was the reason why it was not reproducible. So it's more a problem of installing the system, the software on and off the system. It's a major reason. They didn't give any other reasons. There may be some others. I said most failed. So anyway, about this approach, that you have to clean up your stuff. It's true. You shouldn't feel the need to produce something perfect. So I personally perfectly find it really, really crappy MATLAB code that runs overnight and crashes half of the time, as long as it gives me an idea if this is a direction I should pursue. And I'm really happy about everything, no matter how bad it is. And no one should be ashamed of, some people should be ashamed of their code, but, but usually we all know how it is. It's all in a hurry, the deadline comes, and so, yeah.
Okay, thanks. Are there any direct questions or should? Okay. Good. Thanks, Britta, first.